So in this video, I wanted to talk about the domain and the range. Domain, range. These are two separate ideas. The domain is all the x values that are that define the function. So all x values for the function. The range is all y values, or all outputs, I should say. All outputs for function. So all inputs for function, all outputs for function. I said x values here, but essentially these are inputs for functions, for the function. So that's essentially what a domain, what a range is. So domains are all the x values, or the inputs for the function, and the range is all the y values, or the outputs for the function. So here in this function, if we see this point here, that's the last point that's actually included in the domain. What do I mean by that? Well, all of these x values that I'm shading here in blue, all of these x values are part of the function, because as you can see, all these x values produce y values. But in this case, we don't have any production of y values. So in this case, this is not part of the domain. How can that be the case? Let's say that we had the function, I don't know, f of x is equal to, let's say we had like the square root of x, right? This function right over here. Now, under the radical sign, we cannot have negative numbers, so non-negative. So sometimes people would say x cannot be, or x is greater than 0, right? Some people say this, or greater than or equal to 0, can also be equal to 0. In this case, the domain is this thing right here, because all the x values that are inputs. These are all the x values that can be inputs. The range would be what? Well, you can think about what the range would be. So I'll say this is a domain. And then the range in this case would be y, right? Let's say y, or f of x, right? And if we put in 0, then this is going to be 0. And then if we put in any other positive number, it's going to be a positive number. It's not going to be a negative number ever. If we tagged on a negative here, then that would be a different story. But if we have just this right here, then it's just going to be a positive number, or it can be 0. So y is greater than or equal to 0. It has the same domain and the same range. This is not going to always be the case, but in this case, it is the case. I think in this problem right here, it's not the case. But yeah, that's essentially what we have here. So let's see. So the domain in this case, and this is this problem here now. So the domain in this case and the range, what are they? Well, here the domain is going to be from -4, right? -4 to 2. You can say it like this if you wanted to. This is also a way you can do this, right? You can express it in this like bracket notation, -4 to 2. And this is something that you can do. And if say you had like a discontinuity. What's a discontinuity? Well, a discontinuity, I think I did cover this in previous videos. A discontinuity is like a hole. Say you had like a or a removable discontinuity. This is more of a calculus term, but if you did have something like that, then you'd have a hole here, say for example. In that case, it wouldn't be continuous from -4 to 2, so the domain wouldn't be from -4 to 2. The domain would be from, say this is -1, right? So -4 to -1, but then it wouldn't include it, so you wouldn't have a square bracket, you would have a parentheses, right? Instead of like a parentheses. And then what you do is, since it's still defined here, so it's part of the domain over here, you would do union. This is the union symbol. So it's including, and then -1 to +2. And then 2 is included. So this is how you would do it, right? This is how you do it. And I'll make a separate video on this just to get it in your head. -4 is included, -1 is not included, and then union, -1 is not included, and then 2 is included. But we're not going to use this notation. This is more of a calculus notation. We'll use just a general, like a compound inequality kind of a notation here. -4, and then can be, so -4 less than or equal to x is less than or equal to 2. This is how you would do it. This is a compound inequality, if you remember what that is, essentially. And you can use this notation, or you can use the other notation, but in an algebra class, typically you'd use this notation. And then the range would be the set of y values. Here you see that the y value comes from here to here. Make sure that you don't do from here to here, because that's not correct. If you did it from here to here, that wouldn't be accurate, because you're looking at all the y values that are possible. All the y values. You can think about like drawing an arrow or something. Start from here, go all the way down to all the y values. Okay, so that's from here all the way, so that's 6 all the way to 2. So that's so y, if we have y, or f of x, y, it's going to be 2 is going to be here, and then 6 is going to be here. That's it. So to recap, the domain was all the x values, range was all the y values that are possible for this function, and that's your answer. This is what you would put. So this video was kind of what a domain and range is, plus this problem. I hope you found this video helpful.